Hello everybody, how's everybody doing? CRS here. I am back with another video on motion in a straight line. This particular lecture will tell you how to solve problems which involve calculus, and it's a very important skill because a lot of problems in competitive exams have got a lot to do with calculus, and calculus based problems are exams favorite. So let's begin with a set of questions now. The first question says a particle is initially at rest. It is subjected to a linear acceleration a as shown in the figure. The maximum speed attained by the particle is. You can solve this question logically. It's a very simple question. Initially the particle is at rest. The acceleration has been varying with time, but at any given instant of time the acceleration is always positive, which means it's only in one direction. That means as long as there is acceleration, the body is being accelerated in the same direction. Velocity increases in the same direction. So the direction of acceleration isn't reversing. So the velocity of the body will continuously increase. When that is the case, you can just use the definition of acceleration. What is acceleration then? The change in velocity divided by time. Change in velocity is final velocity minus initial velocity divided by time. Don't you think that the change in velocity here is equal to the area under the acceleration time graph? Because if you just find the area, just look at the dimensions, acceleration into time, that gives you velocity. So the area under the acceleration time graph gives you velocity. Change in velocity gives you change in velocity, and that's what here it is. Well, the change in velocity now is equal to half into base. Base is 11 into height is 10. So the answer you have is 55 meter per second, because the initial velocity is 0, v is the final velocity, and that's the velocity it attains. Option C is the correct answer. You can solve it in 2 minutes. But sir, this lecture was meant to be calculus based problems. How are you planning to solve it with calculus? If that is your question, let's see how to do it. Well, this would be a shortcut. You can call it a shortcut for this problem. But then let's continue and talk about how to solve the same problem using calculus, dear friends. Look at the board. Of course, we have an equation for a straight line. The reason why I spoke about equation of a straight line is because I can see a straight line. And what's the equation of a straight line? Y is equal to mx plus c. That's the equation of a straight line. Well, y is what you are plotting on the y-axis. In this case, it's the acceleration. M is the slope. Let's call these 2 points x1, y1 and x2, y2. When that is the case, how do you find the slope? y2 minus y1 divided by x2 minus x1. y2 is 0, y1 is 10 divided by x2 is 11 minus x1 is 0. And what are you plotting along the x direction? It's time. And c is the y-intercept. It's the place where the line cuts the y-axis, and it's at 10. Simplifying, you have acceleration equal to minus 10 divided by 11 into t plus 10. That's the equation for acceleration that you get. From this, you can find the equation for velocity. Use the definition of velocity, use the definition of acceleration. Acceleration, dear friends, is dv by dt. It's equal to minus 10 divided by 11 into t plus 10. So what does dv become? dv becomes equal to minus 10 divided by 11 t dt plus 10 dt. Right? So what does now v become equal to? Minus 10 divided by 11 into integral of t dt into integral of t dt starting from 0 to t plus 10 into integral of dt starting from 0 to t. That's what you have. Now let's integrate this. We have v equal to minus 10 divided by 11 t square divided by 2 plus 10 into t after applying limits. So 2 ones are 2 5s. V becomes equal to minus 5 divided by 11 t square plus 10t. That's the equation for velocity you have. And do you see? The velocity will go on increasing. I told you the velocity will go on increasing because the acceleration hasn't changed its direction. So at the end of the day, velocity will be only maximum at this point. At this point, it will be maximum. At what time is it maximum? It's maximum at 11 seconds, my friend. Look at that. The acceleration has always been positive, meaning it has been acting in only one direction. You keep pushing a body in the same direction, its velocity will go on increasing. Whether it is increasing by equal amounts in equal intervals of time, that's a different issue. That's not the case here. It's a non-uniform acceleration. Acceleration is changing with time. But at the end of the day, as long as the direction of acceleration doesn't change, the speed of the body continues to increase in that direction. When that is the case, you can just substitute t equal to 11. When you substitute t equal to 11, you have 5 divided by 11 into 11 square plus 10 multiplied by 11. So square gets cancelled. V becomes equal to minus 55 plus 110. So V becomes equal to 55 meter per second. That's the value for velocity. Either ways, you will still get the same answer. You might tell me, sir, this is a very lengthy method. That was easier. But that method that I first used, and I called it a shortcut, can be used when you see a triangle. You can solve with calculus any possible curve that need not be a straight line. So this method is more versatile and you can use it anywhere in a lot of problems. There is no scope of using geometry, by the way. You must use calculus to get to the answer. So you need to learn to do questions using calculus. That's the intention. Let's go to the next question. A particle is located at x equal to 0 at time t equal to 0, starts moving along the positive x direction with a velocity v that varies as v equal to alpha root x. Here, because the question doesn't say about what alpha is, we have to assume it to be a constant. Now, velocity, dear friends, is a function of position, right? What is the displacement of the particle vary as? That is the question to us. How do you solve it? We need to get the displacement of the body as a function of time. And what we have been given is velocity as a function of position, which is also displacement if you're starting from the origin. And that is the case. You need to use the alternative definition for acceleration. And what is that definition? Acceleration is also defined as velocity times velocity gradient, v dv by dx. In the comments, my students should answer. Tell me, how do you get to this place from the definition of acceleration, which is acceleration is defined as rate of change of velocity. From there, how do you get to this? Write in the comments. Now, going further, I want to know how does the acceleration depend on time in the first place. So what I shall do is I will substitute velocity here, differentiate velocity and substitute it here. Let's find out what sort of an acceleration is this body subjected to. Let's find out. Watch. We have dv by dx equal to alpha into 1 by 2 root x, dear friends. Let us put this back into the equation of acceleration. Acceleration now is equal to v. V is alpha root x and dv by dx is alpha divided by 2 root x. Root x gets cancelled. There is alpha into alpha. It becomes alpha square divided by 2. Alas, this is a good result because it turns out that the acceleration is a constant. And when you have a constant acceleration, the three equations of kinematics that you learn come to absolute use. Now, let's write down an equation for displacement, that motion in one dimension with uniform acceleration taught you. S, dear friends, is equal to ut plus half at square. That is the equation. Question says at time t equal to 0, the particle is located at x equal to 0. So, when that is the case, you can just put x equal to 0 because at time t equal to 0, x was 0. If you put x equal to 0, v becomes 0. That means initial velocity of the particle is 0. If the initial velocity of the particle is 0, s would be equal to half at square, a being acceleration, and we found that it is alpha square by 2. It doesn't matter. We are looking at a proportionality. How does it depend on is the question. It depends. Displacement is directly proportional to t square, dear friends, and it's option 3. Look at that. Calculus works its way through if you understand it well. Let's go to the next question. The relation between time t and displacement and distance x is given by t equal to ax squared plus bx, where a and b are constants. The acceleration is, we need to find the acceleration in this case. How do you do that? Well, you've got a nice equation here, but the options given in the question are in terms of velocity. So how do you use that here? Dear friends, this is how you would go ahead. I would like to differentiate this equation with respect to time. When I do that, differentiation of t with respect to time is 1. It's equal to a is a constant. Differentiation of x square with respect to t is 2x dx by dt plus b into dx by dt. Right? So you can pull out whatever comes out as a common factor. I have 2xa here plus b. Dx by dt is rate of change of displacement, and I can write that as velocity. So I've got an equation for velocity, my friends. 1 divided by 2ax plus b, that's what is velocity. How do you get acceleration now? Simple. Acceleration is rate of change of velocity. So you simply differentiate it again with respect to time. Let's go do that. We have dv by dt equal to 1. This is like 2ax plus b to the power of minus 1. And how do you differentiate something like that? N into x power n minus 1, right? Let's differentiate that. Minus 1 divided by 2ax plus b the whole square you will have, and you have to differentiate what is inside brackets now. It's chain rule. Let's do that. We have 2a dx by dt once again. Of course, differentiation of b would be 0. We have dv by dt equal to minus 1 divided by 2ax plus b the whole square multiplied by 2a into velocity, because dx by dt is velocity. Look at what's there in the denominator, 2ax plus b square. What is 2ax plus b? Dear friends, 2ax plus b is equal to 1 by v. Let's substitute that there. We have acceleration a, because dv by dt is acceleration, minus 1 divided by 1 by v the whole square into 2av. The answer you get is a equal to minus 2av cube. So acceleration depends as the third power, the v cube. Do we have an option like that? Looks like it's option 3 once again. Dear friends, that's how you solve problems relating to calculus. I have already told you that these kind of problems keep appearing time and again in all competitive exams. Master solving problems using calculus, and you will see yourself wherever you want to go. But I always tell you in all of my videos, the day you stop learning is the day you start decaying. Let's start working and let's go and solve problems based on calculus. Thank you so much, and see you in the next video.